Okay, so here is an example of a rational expression that they want us to express as a partial fraction. So as always, we need to have a strategy in the head, okay, in the mind, so that the strategy can guide our solution. So our strategy is always going to be, first we check for the degree of the polynomial, okay, or of the polynomials involved or the expressions involved. So this is degree 1, and then that's degree 2. So meaning that this is already in a format that we can already solve. Now, the second thing that we need to look at is, what does this reduce to? Okay, we can already see that this will reduce to 2 distinct factors. Okay, they will not be same factors. If it was something like x squared plus 4x, maybe plus 4, I would know that it will reduce to a square of factors. But here we can see that these will be distinct factors. So already in our minds, we need to know that we are going to be doing the type A kind of partial fraction. So the second is just check the factors of the denominator. Okay, that will guide you in terms of what kind of solution you're going to go for. So here I know that I should go for type A. Okay, but first I need to reduce and prove that actually I can. So I need to go 3x plus 5. Then what do I do here? I'm going to begin to simplify this. So I'll say here, I know that it's 6 minus 6. Then to get minus 5, I'll need to use 2 factors of 6. Okay, now what factors of 6 can I add? And then they give me minus 5. So this will be minus 6x plus x minus 3. Okay, reason being that this is minus 6. I cannot use minus 3 and minus 3 because what's minus 2 and minus 3? Once I can add these to minus 5 quite alright. Okay, but I can't multiply them to give me 6, negative 6. They'll give me plus 6. That's why I'm going for 1 and 6. Just one will have a negative sign. Okay, that's what I've done here. So if I simplify this further, I'll have something like this. Then this will become 2x squared, okay, or 2x. Then this will become x minus 3, then plus 1, x minus 3, like that. Then this will become 3x plus 5, and then this will become 2x plus 1, okay, carefully, and then this becomes x minus 3. Now here you will notice something very very important here. You'll notice something very important. What do we notice here? We notice that we have reached this point here where we know that we've got 2 distinct factors, and we're going to use class A partial fractions. So we're going to write this just the way it is, okay, and this is very, very important step. And then we write this just the way it is as well, okay. Notice that we're being careful here. Then we're going to say this is going to be equal, depends on where who teaches you. You can say equal or equivalent. So this is going to be 2x plus 1, like that, okay, 2x plus 1. And then you're going to say plus, because this is type A, so you have to remember what type A looks like. That's why I say it's very, very important to master those. It's going to be like that. So I've split these, but now my work is not going to be here, and this is where it gets interesting. My work is not going to be here, my work is going to be there. So I expand this, okay. So I have normally you can actually even do it from here, okay. So I'll say 2x plus 1, like that. Then I'll say x minus 1 minus 3. You know how we divide? This cancels with that, this multiplies the a. So a x minus 3, like that, plus b. Notice there, I'm being very careful. So here and that. So I have this one remaining, then I multiplied against B. Then I go on and expand the top part. So the top part and this other top part are going to be equated. So now I can say, because this and that are the same, so I could actually bring this down and say this, and then I'll say 2x plus 1. You notice this? Then I say x minus 3, like that. Then I say these two are equal. That's why I went with the equal sign here, because I knew this was going to come full circle. So this at the bottom and the other one are the same. So I can simply just say this is equal to that, or I can cancel this, okay, because these are going to divide. Depends on how you want to show your work. Okay, so now we can say 3x plus 5 equal to ax minus 3, then plus b, like that, 2x plus 1. Okay, so now these are going to be like that. So now I can continue with this straight away. I'll expand this, so it will be ax minus 3a. Okay, then I'll say plus, okay, b 2x or 2bx plus b, right? I'll now collect the like terms like that, equal to, okay, this ax plus 2bx, like that. Then I'll have 3 minus 3a, right, plus this is just b, so we'll say b here. Okay, you notice that? So now here I can say 3x plus 5 equal to this one. Okay, you notice that this, we can factorize x plus 2b x. Then this, I'll maintain it just the way it is, okay, because there's a plus here. So I'll say plus, then I'll put this inside the brackets. I'll say minus 3a plus b, just like that. Okay, so now I can say this x, these are like terms, so I can equate them. So I'll equate their coefficients. Okay, so I can say a plus 2b equal to 3. Then I'll say minus 3a plus b equal to 5. Now you see that these two are simultaneous equations. Okay. Okay, so we have this. So we're continuing from here. Okay, so now we have this. And now, because these are linear equations in two variables, so we're going to say this one, I'm trying to get rid of the middle part, so I'll say elimination method. So here I'll say times 1, and then here I'll say times negative 2. So we'll have a plus 2b a plus 2b equal to 3. Okay, because it's just multiplying by 1. Then here I'll multiply by negative 2. So this will become 6a. Notice it has become positive. This becomes minus 2b, right? And then here we have minus 10. All right, so we'll do this. Now these two can cancel. So we have 7a equal to, this is minus 7, because now we're just adding. So a is equal to minus 1. Now I can get this into any of the functions here, or the equations, and then I solve for b. So I can say minus 1, I'll get the first one because it's simpler. Then I'll say 2b is equal to 3, right? So this is minus 1 plus 2b is equal to 3, like that. This goes the other side, so 2b is equal to 4, right? Because this goes and adds. Then we can say that b is equal to 2. So now we have a and we have b. a lot of students still have problems at this point because now you've put minus a here, minus 1, okay, at a. So you put minus a there, which is 2x plus 1. This is your partial fraction now. Plus b, we said, was 2 over x minus b, x minus 3. Right? So that's your partial fraction. Now, some students will have problems at this point. Why? Because of the negative that's here on top. Okay, so I want to emphasize that if you have a negative here and you just have one factor here, it is actually the same as putting it here if you have one number there, meaning that you can rewrite this to say 2 over x minus 3 minus this whole structure here, because sometimes I've seen that we have a problem. Let's say it's minus x plus 1 over x plus 1. So students will have a problem with this because they'll say that this is the same as x plus 1 over x plus 1, where you have this. Now notice this becomes 1, which is not true, because once you take this and make it, you use it for the whole thing, it means that now it has affected this one and it has affected this one. So it's the same as putting this in brackets and then you say x minus 1 and then you have x plus 1. Okay, so this now can translate to this minus 1, but look at this, and then x plus 1. So it means that now it's for the whole expression, you see, not just for x, but then it has caused the change here. So this is the thing to understand. So when you do this, it's the same in this case as just putting it here, because there's just one element. But when there's 2 or more elements, you can't just move that negative sign and put it in front of your expression. It will affect all the terms that you have on top here. Okay, so this will be our partial fraction. Okay, and you can actually prove this, because I've seen some questions coming through sometimes. It's how to prove that what you've done is actually correct. So how you prove is that you form this again. Okay, so you can put this and that together, and then you see if it comes back to the same thing that you had in the beginning, which is this one here. Okay, but that will take time. I wouldn't recommend you doing that in an exam. Just carefully follow all the steps and then come to your final answer. All right, let's try another example. We'll try about 5 examples with regards to partial fractions.